My name is Jessica Stewart. I'm a senior software engineer at Slack, and my pronouns are she, her. If you want to connect with me on LinkedIn, you can find me there again as Jessica Stewart, and I welcome any feedback. I heard this morning from Tim that you're able to give me feedback through the app, so please do. I've been at Slack for 1 year, so I'm relatively new. I'm on a distributed team, and I'm based in Atlanta, and my team is the data orchestration team. That means that we own our OLAP solution as well as our workflow management solution. I was excited to join Slack because I am a power user of emojis, and Slack is also big on emojis. This is a snapshot of the current count of custom emojis in their catalog. It's almost 64,000. Today, the theme of the talk will be tacos. If you are not deep in the Tableau ecosystem, that probably doesn't mean much to you, but it will by the end of the talk. The main ingredients for our taco today is going to be our use case, my company Slack, Pinot, Tableau, and a secret sauce that I'll go into more at the end. So I'm just curious, who uses Slack at work? Okay, pretty good. Who uses Tableau at work? Oh, okay, pretty good adoption there too. So I'll go into how we integrate Tableau and Pinot throughout this talk. So first of all, let's talk about Slack. Okay, this is a feature of Slack that you're probably not using every day. It is the admin dashboard that shows analytics on how people are using Slack. So things like how many canvases are they creating, how many messages are they sending, how many huddles are they in. And it's designed for someone who is administering Slack so they can understand how people are engaging with the platform. And this is powered by Pinot. But that's today. Before, this problem was brought to my team. We needed to have a system that could support hundreds of queries per second, low latency with a maximum response time of 10 seconds, but ideally less than 1 second, 99.99% uptime. That's a Slack SLA. So when we make deals with customers, they hold us to keeping that number. Each table needed to be able to support trillions of rows. We needed to be able to customize each table with different indices, and we also needed to be able to leverage data from our existing data lake, which is a combination of S3 and Hive. At the time, we had 2 solutions internally. We had a key value store as well as Solr for search, but they didn't meet all of the requirements, so we needed to go with an OLAP solution. So of all of the OLAP solutions that we have today, why did we decide to go with Pinot? Well, firstly, Pinot offers a tiered storage solution, so we can balance how we want to manage cost versus latency trade-off. Secondly, joins are supported. And lastly, the cluster management solutions. So there's online indexing as well as zero downtime rebalancing. So this is a general diagram of what that architecture looks like. We have users at the top that are interacting with Slack. They're sending data into Vitesse and Kafka. On a daily and hourly basis, that data is going into our S3 data lake. And then on a daily cadence after that, we see the data flow into our OLAP solution, which is Pinot. So let's do a high-level overview of how we're using Pinot at Slack today. We actually have 2 clusters. So you see here that we have our data lake on the left, and then we have 2 different frameworks that ingest data into each of these clusters. So I mentioned that we have the customer-facing analytics dashboard. In addition to that, we also have an internal homegrown analytics tool that allows users to do things like build dashboards, explore metrics, and execute interactive queries. So here is a view of the different metrics. So we have some gold standard metrics at Slack. These are things that the business uses like number of paid customers, retention, et cetera, and those can be browsed through this interface. They need to be very low latency because sometimes we'll have people that are giving presentations to executive level folks, and so we need a very quick, snappy dashboard for them. So all of that is powered with Pinot. To give a sense of scale between this and our data lake has over 130,000 tables, and then in Pinot, we have a very curated set of about 150. And then in terms of the external customer-facing tables, only 15. I mentioned previously that we have 2 different clusters. We're actually not using the Pinot tenancy feature. The reason why is because we wanted to completely decouple our clusters in the way that they're 2 completely different use cases. One is internal, one is external, and they have very different risk profiles. If something is down on our internal cluster, that means employees at Slack are delayed in doing their job. If the external cluster is down, we could be held to paying our customers money because we're breaking contract at that point. Additionally, everything is managed with infrastructure as code through Terraform, Chef, and Kubernetes YAML, so it's easy to duplicate our clusters. All right, so this is what the data ingestion portion looks like. So this is where, to the keen observer, you may be having a big question in your head right now, and that's, why isn't Kafka in this diagram? Why is this not real time? So we actually do not currently have any real-time use cases for Pinot today. It is all batch. And the I'll get into it a little bit later, but basically it has to do with the product requirements. So we ingest everything through our workflow management solution, which is Airflow. Airflow has a operator called a sensor. A sensor is basically something that polls and checks to make sure something is ready. So what our Airflow sensor is doing is saying, is our data in S3? Is our data in S3? Is our data in S3? When it is ready, then we ingest it into Pinot. It first goes into another S3 bucket, which is specifically for our Pinot segments. Then we hit the servers with a note to download all of that data onto the server from those S3 buckets. So this is what the external use case ingestion looks like. We have our engineers who are on that team. They actually manually create schemas for what their data model looks like, and then sync that to Pinot. And then this is the corresponding Airflow DAG that is the jobs that ingests all the data. And this is what the cluster looks like. You'll see on the left, we have our Chef code, which is just Ruby that configures the cluster on EC2 instances. We have 5 brokers, 4 controllers, a Zookeeper cluster with 5 nodes, and offline servers, 155 of those. So that's about 2,500 CPUs and about 10 gigs of memory, 10,000 gigs of memory. And in addition to that, in our S3 deep store, we have about 15 terabytes. This is our internal ingestion. So this is highly automated. Basically, I mentioned that we have those gold standard metrics. It's created through a framework called Merlin. And that allows our data scientists to configure their data sets using YAML. A Boolean value in that YAML is OLAP, true or false. All they have to do is set it to true, and that data will automatically be ingested into Pinot through the DAG there that's created. Also, it automatically handles schema evolution. This is what our internal cluster looks like. Again, this is hosting all of those gold standard metrics. It's defined with Kubernetes. So I mentioned previously we have 2 completely separate clusters. What that allowed us to do is migrate our lower risk cluster to Kubernetes first. So we did that a few months ago. And that Kubernetes YAML is actually an abstraction over raw Kubernetes. So we use EKS. Slack is entirely an AWS shop. And we have a framework or a platform called Bedrock. And it basically takes raw EKS and it enhances it with Slack-specific requirements around security, CI/CD, et cetera. In the internal clusters, we have 4 brokers, 4 controllers, that Zookeeper cluster I mentioned before, and then 22 pods for our offline servers. So what does our usage look like today? Like I mentioned, we have those 2 clusters. One is running with auto-scaling groups, the other is on EKS. We have 165 tables total, 15 terabytes of data, and the largest table is about 96 billion rows. Something that we have improved on over time is our rate to actually from just a product requirement coming up to the data being in Pinot. For the internal cluster, it takes about 1 day because, as I mentioned, it's all automated. For the external cluster, it's intentionally under a heavier due diligence. We do load testing to make sure all the queries are performant. We make sure that the cluster is going to scale. We test different indices. So it's more intensive, but that only takes about a week as well. And 5 more fun facts about running Pinot at Slack. Like I mentioned, nothing is real time at this point. Our freshness requirement is 48 hours, so all those dashboards have a 2-day latency. Also, all of the upstream data that it's using is also not real time. I think the freshest it would be within an hour. Of those features that I mentioned at the beginning of the talk that were the reasons why we decided to go with Pinot, we actually don't use all of them. The ones that we do use are cluster management and indices. We use the sort and inverted indices. But for tiered storage and join support, we just haven't had use cases for them yet. Our cost issues haven't been high enough to require tiered storage, and then we haven't had a join use case yet. However, this is something that we'll more likely see with Tableau. An additional note on the operational side, we created a Python library that's a wrapper around the Pinot API to make some of our standard operations, more codified so that human error can be reduced and also just faster and more convenient to use. On the right-hand side, that's a snapshot of what the CLI help dropdown looks like. And we have 32 commands currently today. And it does things like it'll benchmark queries. We use that when we were migrating to Kubernetes. It will rebalance tables. It will do tagging, et cetera. We also do pool-based instance assignment for our EC2 cluster. I know that the folks at Stripe mentioned that they did this today basically for the exact same reason. And that's we wanted to be able to do upgrades to our cluster as fast as possible. So an example would be we need to do a security patch. We need to upgrade our operating system version. When we did that before, we didn't want more than 1 node to go down at a time. We have a replication of 3 for all of our segments, so we didn't want to risk any of our segments going offline. So because we were sequentially restarting all of those nodes, it would take about 26 hours. But now that we've done pool-based instance assignment, it's down to less than 30 minutes. So we are extremely excited about that. Plans for the future. We did have our first real-time use case come up. It's actually from our data infrastructure team. They want more observability into how Spark is being run. So we're going to be ingesting all of those metrics real-time for them. We also plan to migrate our external cluster to Kubernetes as well. Enter Tableau. So like I mentioned before, at Slack, we have an internal homegrown analytics solution. But as Slack has grown, we want to complement that with the next generation visualization tool, kind of at the enterprise level, and so that's going to be Tableau. It was originally planned to not come to my team at all. It was all going to be interacting with Starburst, aka Trino, aka previously known as Presto, to do all of that querying. However, the data scientists pretty soon came to us and said that they were having some issues. One, the dashboards weren't loading quickly enough. We do find that our Pinot queries versus our Trino connector, that it's about 15 times faster with Pinot. Secondly, they wanted full drag and drop analytics rather than having to use any custom SQL. And then lastly, they wanted an increase in their row limit. So with Pinot, it's 1 million rows, whereas with Trino, it's 50,000. An important thing to note is you need to be running Pinot 1.0 at least to do this integration. The reason why is just to take a step back and think about what Tableau is. It is a drag and drop interface to create visualizations, but behind the scenes, it's executing SQL. And so the drag and drop interface, every possible interaction that a user can do needs to be supported by the SQL that's behind the scenes. And so the folks at StarTree, in order to support this integration, they augmented some of the query language feature set to be able to support this. So examples would be this timestamp data type, also date operations, there are more aggregation functions, the join support, and then aggregations across time windows. Now we're going to get into the Tableau secret sauce. So like I mentioned, this team came to us, they wanted the integration, and the Tableau team actually has an entire team that is devoted to help people create connectors to their data stores. So we partnered with them. They actually have a public-facing SDK to create this connector. The way that you do that is you just get a collection of about half a dozen config files. And what these config files do are, firstly, the main thing that we have needed to customize is the authentication dialog. We put in a bunch of defaults. We have specific validations on those. So we have that customized for our needs. Secondly, this is really the most important file. It's the dialect file, aka the TDD file. It's about 1,000 lines of XML. And what this XML is it's all just the Pinot query language that's mapped to certain functions and operations that you can do in SQL. It needs to be something that Tableau can understand. So this is the file that translates all of that. Once you have all these files in place, you need to package your connector. So they're, again, like I mentioned, the Tableau team, they have a connector plugin SDK that's open sourced, and it's just a Python library that you can use it to both validate your files and then use to package and compile down to what's called a taco file. A taco file is just a jar, but rather than being a file extension of .jar, it's .taco. That stands for Tableau connector. So now that you have your taco created, you need to deploy it. First thing you need to do is open up any of your firewalls. For us, we're using Okta for our authentication solution. Also at Slack, we have a network overlay tool that's open source. It's called Nebula. This is basically our solution for all of our firewalls. So we just configured that so that Tableau could talk to Pinot. Next, you need to take that taco and put it under the connector directory on the far right. And then on the left, you also need to make sure that your Pinot JDBC client is there. And this has two dependencies. One is the calcite core jar as well as the async HTTP client jar. After you have that, one more. You're going to just execute TSM restart on the server. We are using Tableau Server rather than Tableau Cloud, so that's one detail. And then you'll see the Pinot by StarTree connector option. And you just click on that, and this is where you see your auth login. And now you can see your Pinot data display in Tableau. So it took about a quarter for us to get this up and running. And once we got it deployed, we noticed that there is something called the Tableau Data Verification Test Suite. So that's a collection of about 900 tests that run against that SQL file. As you can imagine, that 1,000 lines of SQL configuration, there's plenty of room for very small, tedious errors that have to do with time zones and null values and lots of little specifics like that. So we saw this, and I was talking to the data science team, and I was like, I think we should really QA the connector. And they were like, yeah, I think we should really QA the connector too. However, we were going GA with Tableau and opening this up to all of our users, and we didn't have time to do the testing. The reason why is you have to do some manual data ingestion, do a lot of specific configuration to even get the test to run. So we didn't have time, but I made sure it was a priority for the next quarter. And I raised this as a risk to everyone at Slack, like, hey, we haven't done this verification, but you can start doing basic interactions with Pinot. We ran the test suite the next quarter. and only 18% of those tests were passing. I was at my computer, I'm a remote worker, and I was like, oh my gosh, people are using this to communicate with our executives right now. So I was pretty mortified about that. So I just was, as fast as I possibly could, trying to resolve all these tests. I got up to 50%, and I was talking in the Pinot community, and I was like, hey, has anyone run into this before? Like, I'm trying to get these tests passing. And then I started talking to the folks at StarTree, and we decided that no one should have to experience this pain or this potential threat to their data quality, so we should just open source the connector. So we did that a couple of weeks ago, and this has 93% test passing. In order to be like a gold standard connector, you need 90% passing, so we were able to exceed that. So if you want to run this connector today, it should take a matter of days rather than more than a quarter. So given all of that, I do have some pro tips today that I think would be useful for you to know if you decide to launch this. The first is be mindful of your dates and times. Like I mentioned, we're ingesting all of our data from Hive. So we are downstream of Hive. And the way that all of our Hive partitioning works is it is a year, month, day partition. Tableau is not going to support that. So there are two specific formats that Tableau supports. One, again, this is specific for the Pinot integration, but this kind of goes into how Pinot has multiple ways that you can specify a date. You can do it as a string, you can do it as a timestamp, and then there's lots of different formatting that you can do. But Tableau is a little bit more restricted, so it either needs to be a timestamp or it needs to be a string that's in the format year, month, day, hour, month, second. So what we're doing right now is we are re-ingesting those 150 tables to have the timestamp date type, which really isn't that painful since everything has been automated so heavily, but it's something that would have been good to know from the outset. Secondly, this is actually the second most painful thing about the connector after the dialect file, and that's it's securely signed, which is good from the perspective of security. But when we were getting this going, we went and talked to our security team, and we actually don't have infrastructure at Slack today to do public signing. We don't have certs. And they said that they weren't going to get certs, so we need to do a self-signing, which required us to create like 15 new secrets, and it was very flaky and painful. So then we said, well, what if we just turn the security signing off? And they were like, no, because we have multiple connectors. And so you can only turn off security for all the connectors or for none of them. So we needed to be able to have secure signing for the other connectors that were coming from external sources rather than developed internally. I included the commands for how you can turn it off because that is very useful when testing. But we lucked out because Salesforce, the parent company that owns Slack, they do have this infrastructure. So we're able to leverage kind of an automated system that they have to securely sign our tacos. One good thing to note is right now the folks at StarTree are working on getting a publicly signed taco, so this shouldn't be a pain point for you. Thirdly, null handling. So there is standard SQL null handling, and off the shelf, Pinot is a little bit more customizable in the way that nulls are handled. So in order to have standard null handling with Pinot, you need to specify your null config in two places. One is at ingestion on the left, and then the second config is actually at query time. The way that the connector is designed is when we connect to the JDBC, we specify that null value, so it should be handled for you. And you can also customize that if you'd like. Here is an example of some of the data quality issues that you can run into. So on the left-hand side, with the null handling enabled, the count result is 2. On the right-hand side, it is not set, and the count result is 58. Fourthly, your logs. So So we're running a distributed setup with our Tableau system. So I think we have one primary and like 5 secondary nodes. So all of our logs are distributed across these instances. In addition to that, on each node, Tableau has quite a few logging directories. They have more than 50. And within each of these directories, there are multiple files. So we have hundreds of files that are generating logs. So at Slack, the way that we solve for this is we ship all of our logs to our centralized solution, which is Logstash, so they can be queried. They last for about a week. If you do not have that or haven't set it up yet, you can use a utility that's provided by Tableau. It's the TSM maintenance zip logs command, and then you can download all the files locally. There are no secrets or security PII, no type of information like that in the logs, unless you're like passing a secret through clear text, which is its own issue, but you're safe to kind of search those logs locally. The reason why this is an important feature to be aware of is because inevitably, when you are working with Tableau with any data source, your users are going to come to you and say, why is my dashboard slow? The reason why is because they are not writing those SQL queries. And Tableau does not do a good job of exposing any slow queries to you. All they see is my dashboard isn't going to load. So we have kind of a process now, like our users can find these in Logstash, and also the specific directories where we found them are the data server and the BizQL server. But we're still working on, like right now we're in the process of kind of optimizing some dashboards that are used by executives. But this is something that's kind of a paradigm shift, because before we had these very predefined dashboards that we, before they even went live, we optimized and load tested those queries. But now that we're in the world of like interactive, on-demand dashboarding, we're kind of working on figuring out how to automate the process of, or future-proofing ourselves with our tables so that they are optimized to be queried by Tableau. And then lastly, I mentioned previously that we have a very automated way that we ingest data. It's very low barrier to entry and very little work on the part of the user. What that leads to, anytime you have a really easy self-serve solution, you're going to get a flood of people using the platform. So we did original capacity planning with our research and analytics team for the year, and I think they blew past that within a month, because they were just flipping that Boolean to true for all this data, which is great. It's a good problem to have that so many people want to use the data in Tableau. But we did do 3 things to try and add the appropriate guardrails to the system. So firstly, we set up a Slack alert. Anytime someone creates a new Pinot table, we get an alert. This is really useful if we get a page of like low disk space. We can see all the tables that were recently created. Secondly, it blocks syncing of small files. So like I mentioned, all the data we're ingesting is coming from Hive. And so sometimes we have tables where there are a huge amount of small files, which from the Pinot perspective leads to problems like performance problems when you're ingesting and also when you're querying that data. So we have a block that says, if there are too many small files, it can't be ingested. And we try and go for the, I think it's 100 to 500, bytes, or I think it's megabytes of data is like the optimal size for a segment. Typically, we're a lot lower than that, but for our daily partitioning, we just have it aggregate to the whole day. Lastly, if a table exceeds a certain size, we have a threshold in place. It will be blocked and then require review from our team. And that is pretty much it. Does anyone have any questions?
Thank you. What were you using prior to Pinot? What was your system?
We did not have there was no dashboarding solution that was being used that was powered by our team, at least. I think that we were kind of like the inaugural use case was just to support the dashboarding.
In one of the first slides, you had data going from Kafka to S3 and from S3 to Pinot. I think you mentioned something about that, but can you elaborate a little bit why not ingest from Kafka to Pinot directly?
I don't think that there was. If there was a slide with Kafka, that would have been a mistake because we're not real time at all. So we're not integrated with Kafka at all. All of our data is ingested from the Airflow DAGs. So it's just a daily batch system.
It was Kafka going to S3, but you would ingest from S3.
Oh, okay. So let's. I think maybe what you're referring to is when the user is interacting
from
with the
Vitess and
dashboard.
Kafka going to S3.
Yeah, let's see if we can find that. I think that what this is you're referring to, this one here?
Yeah, this one. Question
Okay.
is, why not directly going from, if you have this structure already, why not ingest the data from Kafka directly?
Sorry, repeat the question one more time.
So data from Kafka goes to S3, and from S3 goes to Pinot, right? So why, now that you have Kafka and S3 and Pinot in one place, why not directly ingest from Kafka?
So, to make it real time?
Real time, low latency, whatever you call it.
Yeah, I think that, well, the idea is that right now that the center S3 is the data lake. It's the source of truth. So everything else needs to be a derivative of that.
Hi, for anyone interested in getting Pinot working with Tableau, do you have any recommendations on resources in addition to the talk you've given?
Yeah, so if you, well, I would recommend, I'll pull it up here, going to the StarTree organization GitHub project, and then within that you'll see the StarTree Tableau connector, and the team at StarTree has been really good. I actually had I had done this all originally by myself, and afterwards I reviewed the README that they created, and it's really useful. In addition to that, the folks at Tableau, they have so much documentation, it's like almost hard to use. So I would suggest just using the README. That's a great place to start, and hopefully the README and the connector that we created will prevent you from having to go to the Tableau docs.
On slide 10, you talked about, you chose, there were some advantages of Pinot over Presto. So I'm curious, what's the use case now you have for Presto? There were 3 bullet points. I remember one was Pinot was 15x faster, and I think number of rows, 50,000 versus 1 million rows, and join support.
Yeah, there were
Right.
2 times when we were basically making a decision. One was when we were deciding on what OLAP solution to use, and then the other was when data scientists came to us and they said, Presto isn't enough. So each one of them had different reasons why. So yeah, for the Pinot, well, what was the original question?
I think you had another slide where you showed Pinot was 15x faster than Presto.
Right, yep.
I think you listed a few reasons. So I'm just curious, is Presto still in play? Yes, this slide. Oh, drag and drop analytics, okay. So I'm curious, I mean, you could still do drag and drop analytics in Tableau using Presto connector.
I think that what they were saying is a lot of things had to be done with custom SQL. So when you, I wonder if you can see it here actually. When you're looking at Tableau, I don't know if you can see it. You can see it here. So on the left-hand side, you can see new custom SQL.
Yeah.
And they were saying they were frequently needing to use
I
that
see.
in order
Okay.
to get the Starburst, AKA Presto connection to work.
Do you still use Presto for any of these use cases?
Yes. Well, again, like I mentioned, so for Tableau today, we're connecting, we have the Starburst connector to connect to execute Presto queries, as well as Pinot. Pinot, because it is more expensive, again, we're duplicating all that data in S3 and on the server, and it also needs to be re-ingested. So that's why we only have that walled garden of 150 metrics, whereas at large within our data lake, there's over 130,000. So it's really a small subset.
Okay, thank you.
Yeah.
Are you performing joins in Tableau with the drag and drop connectors, or how are you using joins today with Pinot?
We are not. We are not using joins today. So for the, again, the external-facing analytics dashboard, that one's highly optimized. So we would almost always just create a big table versus like joining across. For what we're thinking, though, is that for the case of Tableau, because we have much more like ad hoc queries being run, that eventually people are going to start running joins. But I haven't seen a use case yet where people have used it.
And back to slide number 10, what are the different OLAP solutions did you consider and why did you choose Pinot in the end?
The bake-off predates me, but I'm assuming it was probably Druid was the other one that was investigated. Yeah. Okay, if we're all done with questions, I will say if you have any questions about working at Slack or have any interest in working there, feel free to come and talk to me. I've only been there a year, but I can give you a fresh perspective if you're interested. So thanks so much for listening.